Alrighty, back at it with factoring. We're going to do quadratic trinomials part 1. And we'll talk about this, that most quadratic trinomials, we always like to say that that's in the form ax squared plus bx plus c. So for us in this case, our a value there is just going to be a 1. So it's going to turn into x squared plus bx plus c. And then the next one we'll talk about what it's going to be if a is not equal to 1. As it says there, we're looking for two numbers that are going to multiply to our c term and are going to add up to our b term. So for example, on this one, we're going to factor this. So in this case, it's going to multiply to my c term, which is this. So what I like to do is sometimes just kind of write out, it's going to multiply to 6. It's going to add up to my b term, which is going to be a positive 7. And then just start listing things out that would multiply to that 6. So if I do this, I can do 1 and 6. I can do 2 and 3. There are a couple of other things that multiply to 6, such as -1 and -6, -2 and -3. We want to find the ones that also add to 7. If I add 2 and 3 up together, that's going to give me 5. That's not what I want. If I add 1 plus 6, that does give me the 7. And so in this case, those are my two numbers. Now, we want this in factored form. So whenever we factor this, it's a little bit easier this way. We put the x's in front, and then we have what we have. So in this case, I've got a plus 1 because I got a positive 1 from right here. I have a plus 6 because I have a positive 6 from right there. This is our answer. If you want to check to make sure that you did it right, you can simply do the distributive property. So x times x is x squared, x times 6 is 6x. 1 times x, 1 times 6, like that, and that'll add up to this one. Next one. I like to do my two columns. Going to multiply to a -4, and it's going to add to a -3. So listing things that are going to multiply. So here I could do -1, 4, 1, -4. I can do -2 and 2. In this case, if I find out which one's going to add up, -1 plus 4 will give me 3. That's not what I want. 1 plus a -4, that is what I want. And so when I go ahead and write it, get my two parentheses. For these guys, we're going to put the x's in front. I got a +1 and a -4. The order of which these binomials are, that does not matter. But so if I had an x minus 4 first and x plus 1 second, then that would be fine too. And the only reason I'm allowed to put these x's here in front is because my leading coefficient is 1 there. We'll find out on the next video what happens if it's not. Okay. So this time we're going to multiply to a positive 10. So the signs are super important. And we're going to add to a -7. And when a lot of people do this problem, they'll say, okay, 1 and 10 and 2 and 5. And so when they add up 1 and 10, that's 11. When they add up 2 and 5, that's 7. That's not what I'm looking for. But don't forget, we also have 2 negatives multiplied to be a positive. So when I turn it this way, then I have these two numbers. So that gives me -2 times a -5 would give me a positive 10, which is what I'm getting here. But then when I add these two, it also fits the criteria that would add up to my b term. So then x minus 2, and then x minus 5, like that. I've got a few different negatives here to worry about. This is going to multiply to a -24, and it's going to add up to a -10. So this one, once you start getting a little bit higher and lower numbers to these, you start having to write out a bunch. So for example, I got -1 and 24. I've got 1 and -24. So some people like to write them all out. Some people like to stop here and say, okay, well, if I add -1 and 24, that's a positive 23. That's not what I want. 1 plus a -24 is -23. That's not what I want either. So a -2, 12 to -12. So if I multiply, or if I add these guys, -2 plus a 12, that gives me a 10. I want a -10. 2 plus a -12, that does give me a 10. So those are my two numbers. So x plus 2, x minus 12. And again, the order of those parentheses does not matter. If I put the x minus 12 first and then the x plus 2 second, that's 100% fine. The signs are extremely important. So I can't go x minus 2 and x plus 12. That would be incorrect there. Now this one you can look at and you can tell that my leading coefficient is not 1. But one thing to want to point out is you always want to look for a GCF first, and this does have a GCF, so I can factor out a GCF of 2. So if I've got this 2x squared and I divide it by 2, that'll just give me an x squared. If I've got this negative 4x divided by that 2, that'll give me a negative 2x. If I've got that negative 70 divided by 2, that's going to give me a negative 35. And then what do I have left? This is what I can do what I just did before. So it's going to multiply to a negative 35, and it's going to add to a negative 2. So negative 1, 35, 1, and a negative 35. These guys add up to 34. Nope. That adds up to a negative 34. Nope. So I can keep on going. Not divisible by 2 or 3 or 4, but it is 5. So I could do negative 5, 7, 5, negative 7. We want the ones right here. So negative 5 plus 7 will give you 2. That's not what I want. 5 and negative 7 gives you that. That is what I want. So this coefficient, this GCF right there, that's going to stay. And then I have to write my 2 parentheses. Again, the order doesn't matter. This time I'll put the negative 7 first for no reason, just because I can. And then I'll put that. So sometimes always look for a GCF at 2. It'll obviously simplify the problem too. And we'll talk about that also when we get some harder different problems with doing these quadratic trinomials when we are not having an a value of 1 and something else. That will be on the next video.